Hello friends, welcome to VK Lectures. Here we are discussing the Karnataka State 2017 Physics question paper part 1. Some important instructions before going to the video. Here we are discussing KSET 2017 part 1 Physics question paper. Those who are preparing for the KSET exam, I request you to kindly download the question paper from the website and solve the question paper within 2 hours of exam. And kindly use this video after completing your exam for reference and additional information which will boost your confidence for the exam. And those who are preparing for the exam, VK Lectures is providing an online KSET Physics coaching, and those who are willing to take up the coaching can contact in this mobile number. Also you can use it as WhatsApp number. The absolute value of the integral r cross dr around the equilateral triangle of side A with the origin at the center is so now let's say the closed integral over the any curve r cross dr. So this is in around as equilateral triangle. So since this is 2 dimension and it's in xy plane. This is not given, but we have to consider it is in xy plane for better understanding. Now what are r then? If it is in xy plane, r is equal to xi cap plus yj cap. Similarly, dr will be equal to dx I cap plus dy j cap. Now this integral, closed integral or r cross dr will be equal to 2 times the area vector A. And what is this A? A is the area vector perpendicular to the plane that we have already considered. So it will be in the k direction. So area vector is perpendicular to the area which we are considering. Now here is the closed region, and that closed region is nothing but the equilateral triangle with the side A. So we have the magnitude. Absolute value means the magnitude. So that's equal to 2 times area of the triangle, equilateral triangle. So 2 times area of the equilateral triangle with side A is root 3 by 4 A square. So this becomes root 3 by 2 A squared. F of x, this is equal to 1 by root of 2 pi integral from minus infinity to plus infinity f of x times e to the power minus ikx dx, then f square of f of x. Now this is f of x, that means f of x. This is the Fourier transform of f of x. Now the question is, if it is applied twice, then what is the function? So f of x. So one bracket. So f of x, this is equal to f square of f of x. So twice application gives the reflection, and f square of f of x is equal to minus f of x. So f square of the function f of x equal to f of minus x. So, and please remember this, when it is applied 4 times, Fourier transform is applied 4 times to a function, you get the function back. It's equal to f of x. This property is called, this is a property of Fourier transform. Known as iteration property. Two properties are there, iteration properties. One is f square of f of x equal to f of minus x, and f to the power 4 of f of x equal to f of x. These are the two iteration properties of Fourier transform.
The Fourier transform of d by dx of f is related to Fourier transform h of k equal to integral minus infinity to plus infinity e power I kx into f of x dx. Now what is we have is Fourier transform of f of x equal to integral minus infinity to plus infinity e power I kx into f of x dx. That's equal to h of k. Now we want to find out the Fourier transform of first derivative of f of x. Now Fourier transform of f dash of x equal to integral minus infinity to plus infinity e power I kx into d by dx of f of x dx equal to dash. This is what we have to find. Okay, now for that, integral uv is equal to u into integral v minus integral of derivative of u into integral v. This is what we have to find, uv integration. Okay, all right, now substitute this u and v. U equal to e power I kx and v equal to d by dx of f of x. Now for that, u, let us write e power I kx into integral v is nothing but f of x from minus infinity to plus infinity minus integral derivative of u, derivative of e power I kx is nothing but ik into e power I kx into f of x dx minus infinity to plus infinity. Now there is a property for this Fourier transform, this function f of x tending to 0 as x tends to plus or minus infinity. That means as x is tending to infinity values, your function will be tending to 0. Okay, then this quantity will be equal to 0, e power I kx into f of x from minus infinity to plus infinity. Now what is remaining is this particular term, that is equal to minus ik into integral minus infinity to plus infinity e power I kx into f of x dx. Now what is this? This is nothing but h of k from here to here, integral minus infinity to plus infinity e power I kx into f of x dx is nothing but h of k. So we can write this as ik minus ik into h of k. So your option is minus ik into h of k. Option C. Right. The value of the integral, closed integral over c, z square into dz, where c is the unit circle is. So this integral is what we have to find. Now let us write what is z is equal to. Z is equal to r e power I theta. Okay, now it is given c is a unit circle, which means radius is equal to 1. So z we can write it as e power I theta, and we need z square. So z square will be equal to e power 2I theta, and we need dz. What is dz? Dz will be e power I theta into I d theta, right? I d theta. Okay, so we have the quantities whatever we required. Then we want to find out the integral over c z square dz. Z square is nothing but e power 2I theta into I e power I theta into d theta. All right, now this is closed integral, so we can write this as integral from 0 to 2 pi. Okay, e power 2I theta into e power I theta, that is e power 3I theta, and one I will be outside. Okay, into d theta. So I remaining outside. This integral is nothing but e power 3I theta divided by 3I, from where to where? 0 to 2 pi. Okay, now I and I here get cancelled. 1 by 3 into e power 3I theta, from where to where? 0 to 2 pi. Now substitute the values. Upper limit first, 1 by 3 into e power 6I pi, therefore I into 6 pi minus e power I into 0. Right, e power 6I pi is nothing but 0. So 1, this quantity is 1 minus 1. So how we'll write e power I theta? E power I theta is nothing but cos theta plus I sin theta. So since it is 2 pi value, sin theta will get removed. Cos 2 pi is nothing but 1. Cos 0 is nothing but 1. Cos 6 pi is nothing but 1. Okay, so 1 by 3 into 1 minus 1, which is equal to 0. So your answer is option B, 0. The value of the integral 1 by pi I integral over c dz divided by z square minus 1, where the contour c is a circle of radius a not equal to 1 with the origin. Now let us take this integral dz divided by z square minus 1. This we can write it as integral dz divided by z plus 1 into z minus 1. Okay, now from here we can write the poles. What are the poles? Z equal to minus 1 and z equal to plus 1. These are the poles. Z equal to minus 1 from this and z equal to plus 1 from this. Okay, now we got the poles. Now coming to the question where you see a not equal to 1. A not equal to 1 means there are two possibilities, either a greater than 1 or a less than 1. Okay, for a greater than 1, we can write the poles are inside, right? A greater than 1 at origin means, so this is your origin and this is your A, Okay, and this is your 1, this is your minus 1. Both are for a greater than 1. This plus 1 and minus 1 will be inside this contour. Then your integral dz divided by z square minus 1 will be sum over residues. What is sum of residues? d1 divided by z square minus 1, right? Take the differentiation of z square minus 1, that will be 2z at z equal to minus 1 plus 1 by 2z at z is equal to plus 1 equal to what? That's equal to 1 by 2z at z equal to minus 1 means minus 1 by 2 plus 1 by 2z at z equal to plus 1 means 1 by 2, which is equal to 0. So integral is 0. Now we have another possibility, a less than 1. If a is less than 1, that means your poles are outside, that means somewhere here. This is your radius with a and these are your poles. Pole is outside this contour, okay, which means your integral dz divided by z square minus 1 equal to 0, because the poles are outside. Now whether the poles are inside or outside, your integral is 0. For a less than 1, sorry, a greater than 1, your integral is 0, and for a less than 1, your integral is 0. So either way answer is 0 and independent of a. Okay, so that's it. Consider the matrix A equal to this. Now the product of eigenvalue. Now product of eigenvalues is nothing but our determinant. So if you are asked to find out the determinant, just find out the product of the eigenvalues if eigenvalues are given. Now what is the determinant? 1 into 6 plus 6, so minus 6, so 1 into minus 6 plus 6 plus 1 into minus 1 into minus 15 plus 12, 3 into minus 5 plus 4. So here you have 0, here plus 3, 0 plus 3 minus 3, so that's equal to 0. So product of this eigenvalue is equal to 0, which means determinant equal to 0. So determinant equal to 0 implies product of eigenvalues equal to 0. Now since it is a 3 by 3 matrix, you have lambda 1, lambda 2, lambda 3 as eigenvalues, okay, which means either any one of them, either lambda 1, lambda 2 or lambda 3, any one of them should be equal to 0, okay, only then this product will be equal to 0. So here you are asked only the product of eigenvalues, which is nothing but the determinant, which is equal to 0. Now what is trace? Trace is equal to sum of eigenvalue, which is nothing but sum of diagonal elements. What is the diagonal element sum here? 1 plus 2 minus 3. So trace is also equal to 0. Okay. average value of a function f of x equal to sin x in the interval 0 less than or equal to x less than or equal to pi. Now average value of any function f of x is given by let me write it as f of x bar. So that is equal to integral f of x dx divided by integral dx. Anything, for example, if you want to find out the average value of f of x squared, then what you have to do? Integral f of x whole squared dx divided by integral dx. This is if it is in one dimension. For similarly, if you have it in two dimension, you have to integrate over two dimension. Integral dx, integral dy will be there. Okay. Now here the question is f of x equal to sin x and the interval is given. So integral sin x dx from where to where? 0 to pi, and integral dx from where to where? 0 to pi. So sin x integral is nothing but minus cos x from where to where? 0 to pi divided by dx, that is x from 0 to pi. So since it is minus, let us first put lower limit. Cos 0 is 1, cos pi is minus 1. So 1 minus minus 1 divided by x, which is nothing but pi. So that is equal to 2 divided by pi. So 2 by pi, your option is P. Eigenvalues of real 3 by 3 matrix. Now what do you mean by real 3 by 3 matrix? All elements are real. Okay, if all elements are real. Now let us understand about the trace of this matrix. Trace of the matrix will be equal to real. Why? Because trace means sum of diagonal elements. Okay, so sum of the diagonal elements must be real because this is a real matrix. Now let me write sum of diagonal elements equal to what? Sum of eigenvalues. So since it is 3 by 3, there are 3 eigenvalues, lambda 1, lambda 2 and lambda 3. So this sum lambda 1 plus lambda 2 plus lambda 3 must be equal to real. Okay, yeah. Now comes what are these lambda 1, lambda 2 and lambda 3. Now if there exists a complex number, okay, let me write lambda 1 is equal to x plus iy, lambda 1 equal to x plus iy, then there must be lambda 2 which is equal to x minus iy. Complex conjugate should exist. Now only if there is a complex number, its conjugate should exist. Okay, now so lambda 1, lambda 2 over. So what about lambda 3? Then lambda 3 must be real. Okay, so either all lambda 1, lambda 2, lambda 3 are real. Suppose there is a complex number, its complex conjugate also should exist. That means your lambda 3 must be real. That means one eigenvalue must be real. Okay, there is no guarantee about lambda 1, lambda 2, but lambda 3 must be real. That means either one, at least one should be this real. Now this is not possible. All eigenvalues imaginary. No. For a real matrix, if one of the eigenvalue is complex, then another is its complex conjugate. Suppose there is a question, okay, there is a real matrix A and lambda 1 is equal to 2 plus I, lambda 2 is equal to 2, and what about lambda 3? Lambda 3 should be 2 minus I. Should be 2 minus I. Okay. Matrix 3 by 3 has an eigenvalue 0, 2 plus I and 2 minus I. Which of the following statement is correct? Now, the 3 by 3 matrix lambda 1, lambda 2 and lambda 3. 0, 2 plus I and 2 minus I. Okay. So, coming to the options, what is Hermitian? Hermitian means A dagger equal to A. Now what is A dagger? A dagger is nothing but take the complex conjugate of A, then take the transpose, or take the transpose and then take the complex conjugate. Operations are independent. Okay. Now what is unitary matrix? Unitary matrix means A dagger into A equal to I, or A into A dagger equal to I. Now we know A into A inverse equal to I. Now A into A dagger equal to I and A into A inverse equal to I, which means A inverse is equal to A dagger. That means for a unitary matrix, A inverse is nothing but A dagger. Okay. Now coming to the third one, singular. What is singular? Determinant equal to 0. Determinant equal to 0 means either lambda 1, lambda 2 into lambda 3 equal to 0. Either any one of them should be equal to 0. Product is 0, determinant, or any one of the eigenvalue must be equal to 0. Now determinant not equal to 0. This is called non-singular. Non-singular. Non-singular means lambda 1, comma lambda 2, comma lambda 3 should not be equal to 0. Okay. None of the eigenvalues should be equal to 0. It should not be 0. Alright. Now coming back to the question. The lambdas are given. Lambda 1, lambda 2 and lambda 3. Now what is lambda 1 into lambda 2 into lambda 3? Lambda 1 into lambda 2 into lambda 3 is nothing but 0 because you have eigenvalue 0. So this is a example of non-singular matrix. Non-singular matrix.
There are 40 persons in a row, all born in the month of April. The probability that at least 2 of them share the same birthday is closest to 2. Now we have 40 persons. 40 persons are available, and in the month of April we have 30 days. Now suppose every person has different birthday. If every person has different birthdays, then there must be 40 days in the month of April, but we do not have that number of days in that month of April. Now okay, now since we do not have 40 days, that means each person needs, or there must be 40 days in April to have distinct birthday. If it is less than 40, then at least 2% have to share same birthday. Okay, so probability is equal to 1. Four options are given in the for this question, and closest to is 0.9, but we cannot write it closest to 0.9 is a wrong option. Probability is equal to 1 is the correct answer.
A particle of mass m is thrown upward from the surface of the earth with initial velocity component ux and uy along the horizontal and vertical directions respectively. The trajectory therefore is given by the along x-axis. The distance is given by ux t, that means velocity along the x direction into time, and y of t, that means your distance covered along the direction y, uy into t minus half gt squared. Now the question is the instant of time at which acceleration and velocity vectors are perpendicular to each other. Now for example, here you have this mass m which is thrown. Now this is your velocity direction along y, and this is velocity along x. Alright, now our acceleration will be always towards downward direction, which is gravity. Okay, so this gravity will be always downward. Now we have to find a point where this g and the velocity of the particle is perpendicular to each other. Now look at this highest point. At this highest point you do not have a component of uy. You do not have uy equal to 0 here. So gravity is always downward, and the only velocity you have is ux, that means velocity along x direction. Now so this is the point what we required. Okay, now to find that point, you know uy equal to 0. Uy equal to 0 means y of t is given. Y of t is equal to uy into t minus half gt squared. This uy equal to 0 means y dash of t equal to 0, which means take the derivative of this y of t. What you are getting is uy minus gt equal to 0. At this point you can write uy equal to gt. Now what you want? You want time, what the instant of time. From here you can write t is equal to uy by g. So this is what is required, time at which your velocity vector and your gravity are perpendicular to each other. So your option is option A. Phase curve of a freely falling body. Now what do you mean by phase curve? Phase curve simply means phase space trajectory. Now what is phase space trajectory? It is a curve between position and momentum. Okay, so we had to find out how a freely falling body under gravity behaves. Now we can write your total energy of a freely falling body is equal to half mv squared plus mgh, or you can write mgx. Okay, now this we can write it as kinetic energy is equal to p squared divided by 2m, where p is momentum, plus mgx, just to write energy in terms of position and momentum. Now at momentum equal to 0, when will be the momentum equal to 0? At the initial position. At momentum equal to 0, your energy is equal to mgx, which means energy is proportional to x. Now at x equal to 0, your energy is equal to p squared divided by 2m, and which means energy is proportional to p squared. Now you have two equations, that is energy is proportional to x and energy is proportional to p squared. Then we can write x is proportional to p squared. Alright, or we can write x is equal to some constant k into p squared. Now this is a graph of square curve. So how it will be y equal to x square. So how is y is equal to x square curve? In this way, y equal to x square curve, where along x you have position and along p you have momentum. Sorry, along y you have momentum. So this is hyperbola. Ellipse is for linear harmonic oscillator. Linear harmonic oscillator, you have elliptical shape for phase space. The fixed point of a one-dimensional harmonic oscillator obeying the dynamical equation x double dot plus omega square x equal to 0 is. Now from the question nothing is clear, but from the option what I expect is they are talking about phase space trajectory. Phase space trajectory of linear harmonic oscillator. Okay, so from linear harmonics we can say energy is equal to p squared divided by 2m, that is kinetic energy of the linear harmonic oscillator, and potential energy is equal to half kx square. Now this equation I can divide by E and rewrite it as p squared divided by 2me plus x squared divided by 2e by k equal to 1. Just dividing the first equation by E. Dividing by E. This we can make a little more modification here. P squared divided by under root 2me whole squared plus x squared divided by under root 2e by k whole squared equal to 1. This equation resembles x squared divided by a square plus y squared divided by b square equal to 1. And now what is this? This is equation of ellipse. Okay, where from the linear harmonic oscillator A is equal to this one, under root 2me, and B is equal to under root 2e divided by k, where A is semi major axis and B is semi minor axis. Okay, So space-wise trajectory of linear harmonic oscillator obeys elliptical path, and where semi-major axis and semi-minor axis are under root 2 me and under root 2 e by k respectively. A planet is revolving around a star in an elliptical orbit. The ratio of furthest distance to the closest distance of the planet from the star is 1.5. The eccentricity of the orbit. Now the eccentricity epsilon is given by c divided by a. Now what is c is equal to? C is equal to under root a square minus b squared. Now from the question we can write the furthest distance, ratio of the furthest distance, that is a by b, that is closest distance, is equal to 1.5, which means a is equal to 1.5 times b. Now just substitute this equation here. A value in c. Okay, so c is equal to under root 1.5 squared minus 1 into b. Take the b outside. So what you are getting is under root 1.25 b, that is equal to c, right? Now the question is, what is eccentricity? C divided by a. So eccentricity is equal to c divided by a is equal to under root 1.25 b divided by a is equal to 1.5 b. 1.5 b. This we can write it as under root 1.25 divided by under root 2.25, which is equal to 5 divided by 9 under root. So 5 by 9 is almost equal to 5.1. 5 point what is left is 45. 5.5, so 0.55 under root 0.55, which is nothing but nearly equal to 0.75. So none of the value is equal to 0.75, but in the option it is given b, but your correct value of eccentricity is 0.75, and equation of ellipse is x square divided by a square plus y square divided by b square equal to 1, and this is a, which is semi-major axis, and this is b, which is semi-minor axis. Okay, c, as we have already discussed, is given by under root a square minus b square, and this becomes a Pythagoras. C b, that means a squared is equal to b square plus c square. Particle experiences a force F is equal to r dot into vector r, where vector r denotes the instantaneous position vector of the particle. Then the force is identified to be. Now we can write r is a vector, r is a position vector, which means r dot is nothing but velocity. Now if a force, if we can write it as is a function of velocity, then the force is non-conservative force. Very good example is our viscous force or retarding force, where we can write F is equal to to minus bv squared or minus bv, where negative sign indicates the force is opposite to velocity. Okay. Alright. So the first part is clear. Since the force is a function of velocity, it is a non-conservative force. Now our force is function of r, which means force acts radially. Radially means it is a central force. Central force. Along the radius it acts. That means if you have a center here, force will be acting in this way, just like our gravitational force or electrostatic force. All are example of central force. Okay, which depends on r, f of r. So it is a central force and non-conservative force. So your option is option D.
Question number 16. The Lagrangian L is given by L is equal to root of 1 plus dy by dx whole square. Okay, where y of x is a function of x, the stationary condition on the action. So this is the action S from integral from x1 to x2 L dx with the fixed points x1 and x2 leads to one of the following expressions with a b as constant. Okay, now let's say let's rewrite this. Let's write y dash is equal to dy by dx. So this is y dash. Then the Lagrangian we can write it as equal to root of 1 plus y dash squared. Fine. Now from the Euler Lagrangian equation, y of x, for the equation y of x, we can write dou L divided by dou y minus d by dx of dou L divided by dou y dash is equal to 0. Now look at the expression L. L is a function of y dash and not a function of y. So L is not equal to L of y, which means first derivative of L with respect to y will be equal to 0. So the first term here goes to 0. So this becomes d by dx of dou L divided by dou y dash equal to 0. So first derivative of this function becomes 0, means dou L divided by dou y dash equal to a constant c. Fine. First derivative is of a function is constant, equal to 0, means that function is constant. Okay, so this much we did. Now we need to understand what is dou L by dou y dash. What is dou L by dou y dash? For that we know L is equal to 1 plus y dash square under root, or we can also write 1 plus y dash squared to the power 1 by 2. Now let's write what is dou L by dou y dash. So dou L divided by dou y dash is equal to, take half out, so half y dash square derivative is 2 times y dash times the function itself, that is 1 plus y dash square to the power minus 1 by 2. 1 by 2 minus 1, that is minus 1 by 2. Now what we have here, 2 gets cancelled. This becomes y dash divided by the root will come down, so let's write here root of 1 plus y dash square. So what we have just written is dou L by dou y dash equal to some constant, and that constant is equal to y dash divided by root of 1 plus y dash square. Now let's write it as some constant c. Now for simplicity, let us square it. Squaring, what we get is y dash square divided by 1 plus y dash square equal to c square. Now let's say we need y dash square, so y dash square equal to c square plus c square into y dash square. So y dash square minus c square into y dash square equal to c square. Bring y dash square, 1 minus c square equal to c square. So y dash square equal to c square divided by 1 minus c square. Now y dash is equal to root of c square divided by 1 minus c square. Now the right hand side itself is one constant k. Let's write it as k. So what we get is dy by dx equal to k. On integration, what you get, y is equal to k x plus some constant c. So this is of the form straight line. Straight line cutting at c with the slope k. So this is of the form ax plus b.
A particle of mass m is subjected to one-dimensional potential. V of x is equal to minus half kx square plus lambda by 4 into x power 4. If the particle executes small amplitude oscillation about the minimum of the potential, the frequency of oscillation is, so we have to find omega. Lambda and k in the given equation for V are positive constant. Now omega is equal to under root k by m. Okay, now that is equal to 1 under root 1 by m into dou square v by dou x square at x equal to a, where a is a stable point. This is what we require. Now to find out x, first we have to put v dash of x equal to 0. By doing this, we are finding equilibrium points. Okay, equilibrium points. From that equilibrium point we need stable equilibrium. Only then oscillations will take place. Now what is v dash of x equal to 0 implies? This v of x we have to differentiate with respect to x. That is equal to minus kx plus lambda x to the power 3 equal to 0, which means k is equal to lambda x square. From that x square will be equal to k divided by lambda. So we got x. Okay, x will be equal to under root k by lambda plus or minus. But we need second derivative of v. So v double dash of x is equal to, differentiate this equation, minus k plus 3 times lambda x square. So now substitute value of x square here. So minus k plus 3 times lambda into x square is nothing but k divided by lambda. So lambda gets cancelled. What you are left with is 2k. So v double dash of x at x equal to k by x square equal to k by lambda. Okay, that is equal to 2k. Now we need omega. Omega is equal to under root 1 by m into dou square v by dou x square at x equal to, what you have to write, dou square v by dou x square at x equal to under root k by lambda. So that what you are getting, 2k. So omega is equal to under root 1 by m into 2k. So that is equal to 2k by m under root. So your option is option D, under root 2k by m. This is the frequency of oscillation.
To the question number 18, the elements of moment of inertia tensor of a rigid body expressed as 3 by 3 matrix in the body fixed coordinate system as I is equal to I naught 0 0 0 2 I naught 0 I naught 2 I naught, where I naught is greater than 0. The rigid body is, we have to find out the type of the rigid body. Okay, now let's find out the eigenvalues for this. Eigenvalues for a matrix similar to this, A 0 0 0 B C 0 C B. Okay. The eigenvalues are lambda equal to, or lambda 1 equal to A. So eigenvalue, first eigenvalue is the first element. Lambda 2, the second eigenvalue, is from this matrix. So that will be equal to B plus C, and lambda 3 equal to B minus C. Okay, these are the eigenvalues. Now bringing this matrix into this tensor, inertia tensor, we will have lambda 1 equal to I naught, lambda 2 equal to 2 I naught plus I naught, lambda 3 equal to 2 I naught minus I naught. Okay, so this one corresponds to x-axis, this is y-axis, z-axis. So now lambda 1, lambda 2 and lambda 3. So lambda 1 equal to I naught, lambda 2 equal to 3 I naught, and lambda 3 equal to again I naught. So it is symmetric with respect to x and z axis. and with respect to y it's not. Okay, so if x-axis, length y and z are equal, this will be spherical. Along x, y and z you have same moment of inertia, then it will be spherical. Or eigenvalues are same, then it will be spherical. But this is symmetric because it's symmetric with respect to the axis y axis. So it's symmetric with respect to y axis means on both x and z axis it will be same along z. So the material will be some kind of a block, where moment of inertia on x and z axis is same. So it's a symmetric. 19. Which of the following gives valid upper and lower bounds on the angle theta between the angular momentum L and the angular velocity omega of the rigid body? Now let's have the relation between the angular momentum L and the angular velocity omega. So L is equal to I omega, where I is the moment of inertia. Now for a symmetric body, the angle between L and omega is 0. So the angle between L and omega is 0, which means both are parallel, that is L parallel to omega. So we got the one value of theta. So theta starts from, or theta equal to 0 for symmetric, so it's the initial value. Now for non-symmetric or any general body or general rigid body, this L and omega are not parallel, but we know that L dot omega equal to L magnitude of L into magnitude of omega times cos theta. Now we need to find what is cos theta. Cos theta equal to L dot omega divided by magnitude of L into magnitude of omega, and this value cannot be negative. All are positive values. So since this cannot be negative, the theta should be less than 90 degree. So theta is less than 90 and it also cannot go beyond 0. So theta value varies from 0 to 90 or pi by 2. So 0 to pi by 2. So option D is the correct.
Volume of a sphere is V0 in its rest frame. Now its volume V in an inertial frame moving with speed c by 2 along x-axis relative to the rest frame. So this is the rest frame S and this is the moving frame S dash, which is moving along x-axis, and this is y and this is x. This is y. Now we can write the radius along y, this is radius along x, this is radius along y in S dash, and this is radius along x axis in the S dash frame. Now you see this is moving in x direction, x axis, which means the contraction of the length contraction, length contracts in x direction. Now what you are seeing is, see here in a non-moving frame, rest frame, Rx and Ry are equal, and when it comes to the moving frame, that is moving with some velocity, that is c by 2, then this is equal to this. There is a reduction Rx. So now you can see the volume clearly decreases. Here you have V naught, here it decreases. Okay, so what is it? The new volume is V. This V will be always less than V naught. Okay, so our option is A, V less than V naught. Electric flux through any closed surface is a measure of. Now let us understand what is electric flux. Flux phi is equal to E bar dot S bar. S is nothing but surface, or you can write area vector. S is area vector, or you can write E bar dot A bar also. Now this flux is due to what? For example, I am considering a thin sheet. Okay, what is the flux? Flux means number of field lines passing through this. What do you mean by flux? Number of field lines passing through an area. Okay, now when we will say that there is an electric field, some charges are kept. If some charges are kept, these charges will produce electric field. This electric field will produce electric field lines, which when it passes through a given surface area, we call it as flux phi. Now suppose we have an area and I have placed one positive charge Q here. So there are electric field lines passing through this field. Okay, now what I am doing is I am placing another charge plus Q at some other distance, not the same distance as this. So there will be an electric field in the opposite direction, because this is also positive charge. It will be electric field lines will be radially outward. So phi flux will be equal to E net, that means net electric field into area. Now this phi is due to what? This phi is due to both the charges kept on either side, and if both the charges are equal and opposite and kept at same distance from the sheet, then net electric field E will be equal to 0. Then there will be no flux. Okay, no flux. So this is the idea. Now coming to the question. In a closed surface, let me assume this is a closed surface. Okay, I have placed a charge Q, then flux phi is due to E dot ds, e bar dot ds, y e bar, or let me write integral e bar dot ds, y integral e bar dot ds, because electric field at all the surface are not same. It varies because when you keep an point charge here, the distance, all the distance may not be same, only some specific distance are same. So phi will be equal to integral e bar dot ds bar. Now in this case, this phi is due to q inside. Now suppose I have placed another charge outside, then total flux phi will be equal to integral e bar dot ds bar plus integral, let me write this as e1, this is q1, this is q2, plus integral e2 bar dot ds bar. Okay, even then this flux is due to both the field, both the charges. Now what happens is, due to outside charge, due to charge kept at outside, no flux will be there, because whatever the electric field lines of force passing through one surface will move to the other surface, move out from the any other surface. That means net flux due to q2 will be equal to 0. Therefore our phi is due to q inside only. Generally we have to take total charge both inside and outside, but here outside charge, whatever the electric field produced, the electric field lines of force will pass through it. Okay, such that the net flux due to outside charge is 0. That is why phi will be due to only charge inside. So the total charge inside the surface, the flux is due to total charge inside the surface. Your option A is correct. Which of the following Maxwell's equation need modification on assumption of existence of magnetic monopoles? Which means that if magnetic monopole exists, magnetic monopoles exist, which of the following equation need to be changed? Now let us take this first Maxwell's equation, that is del dot D equal to rho, or del dot E is equal to rho by epsilon naught. This is Gauss law in divergent form. Law in divergent form. Okay. Now what is it saying? Del dot E is equal to rho by epsilon naught. Suppose this charge, that means what? Gauss law, integral E bar dot ds bar equal to q by epsilon naught. We are talking about the charge in a closed sphere or any closed surface. Charge in this closed surface, let I am considering it as charge q, is equal to E dot ds, that is equal to q by epsilon naught. Correct. Now suppose charge also existed. Let me put in this way. charge also existed in multipoles. That means both positive and negative charge together, just as dipoles. Okay, if this charge existed in dipoles, there would be plus charge, there would be minus charge together, which means closed integral E bar dot ds bar will be equal to 0 because net charge is 0, which implies that del dot E equal to 0. That means if charges existed in as dipoles, okay, then your del dot E will be equal to 0. Likewise, del dot B is equal to 0 because a magnetic dipoles are present. Okay, for magnetic dipoles are present. Magnet exists in two poles, right? North and south. Suppose you can take out north and south separately, then your del dot B would not be equal to 0. There would be some value like rho. So which of the following option is correct? Del dot B equal to 0. That is second Maxwell's equation must be corrected. Match the following. Biot-Savart law. Now what does Biot-Savart law? If there is a current carrying wire, this is small length element dl which is carrying current I at a distance r with a position vector r vector. The magnetic field, small change in magnetic field, small magnetic field dB is equal to mu naught by 4 pi into I dl sin theta divided by r squared. Okay, now this is nothing but mu naught by 4 pi I dl cross r cap divided by r square. Now suppose if this is vector r, mu naught by 4 pi I dl cross vector r, then the denominator should be r cube. So if you consider it as mu naught by 4 pi as 1 by c, then you can write 1 by c into I dl cross r cap. Now you can slightly change this one. So your Biot-Savart law is option B. Okay. Now what is Gauss law? Gauss law says integral E bar dot ds bar equal to q by epsilon naught. In divergent form you can write del dot E is equal to rho by epsilon naught. So del dot E is equal to rho by epsilon naught, that is Gauss law. Now we know Ampere's law. Ampere's law is nothing but integral B bar dot dl bar equal to mu naught times I encircled. Okay. Now this we can write it as integral del cross B dot ds equal to mu naught I encircled. Now this we can write it as integral ds is nothing but area, del cross B is equal to mu naught I encircled by area. I by area is nothing but current density, that is J. So which means del cross B equal to mu naught J. So your Ampere's law is nothing but fourth one. Now integral E bar dot dl bar, that's equal to, again we can write it as integral del cross E dot ds equal to 0, which means del cross E equal to 0. Integral ds cannot be equal to 0, so del cross E should be equal to 0. Now this is for charge free region. Okay, so P to 2, so P to 2 and Q to 3, so P to 2, Q to 3, there's only one option, so option C. A plane polarized light is refracted by a dielectric medium of refractive index mu. If the angle of incidence is I is equal to tan inverse mu, then angle of refraction. Now what is given in the question is I is equal to tan inverse of mu. So here we can write tan I is equal to mu, which means sin I by cos I is equal to mu, right? Now this is from the question, but from Snell's law we have sin I by sin R equal to mu. Okay, now just compare equation 1 and 2, we get cos I equal to sin R. Okay, cos I equal to sin R. Then this we can write it as cos I is equal to sin of 90 minus I equal to sin R. Cos I is nothing but sin of 90 minus I, which is equal to sin R. So sin of 90 minus I equal to R, that means 90 minus I is equal to R. Okay, this is what we want, angle of refraction. So R is equal to I 90 minus I. Now just substitute what is I equal to tan inverse of mu. So 90 minus tan inverse of mu. So your option is R is equal to pi by 2 minus tan inverse mu. A parallel plate capacitor is filled with an insulating material of dielectric constant epsilon R. As a result, the following effects are observed. Now let us see what happens to the capacitance of a parallel plate capacitor when a dielectric constant is introduced. If you have a capacitor, parallel plate capacitor here with capacitance C0, and this is air, and when I introduce a dielectric constant with dielectric constant epsilon R, I am introducing a dielectric material with the dielectric constant epsilon R, then the C dash, that means the new capacitance will be equal to epsilon R times C0. That means capacitance increases because epsilon R will be greater than 1. Okay, so capacitance increase. Now coming to the capacitor, parallel plate capacitor, you know the total charge Q equal to CV, or in terms of V we can write V is equal to Q by C. Okay, now this is your V equal to Q by C naught before introducing the dielectric medium. Now V dash will be equal to Q divided by C naught C dash. What is C dash? C dash is equal to epsilon R times C naught. So Q divided by epsilon R C naught. Since denominator is increasing, V dash or potential decreases. Similarly, electric field also will decrease. Both potential and electric field decreases, so there will be a reduction. The dielectric will reduce electric field and potential difference, while capacitance will increase. Charge will remain constant. Charge is constant. Okay, because charge depends on external supply. Charge depends on external supply, so this will remain constant, while capacitance will increase and potential also will decrease. Electric field in a source free region is given by E is equal to xi cap plus by j cap. Now what we have to see here is just apply Maxwell's equation. Maxwell's equation in source free region. So since we can, it is talking about electric field, we can write del dot E is equal to rho by epsilon naught. Since it is a source free region, del dot E will be equal to 0. Del dot E means I dou by dou x plus j dou by dou y dot xi cap plus by j cap equal to 0. I into dou by dou x dot xi cap, which is nothing but 1, plus I j into j cap dot j cap is 1, dou by dou x, y of by is nothing but b equal to 0, which means b equal to minus 1. So option A. Consider three charges 2q, minus q and minus q kept at a distance 0, 0, 0, a, 0, 0, 0 and 0, 0, minus a. Now since xy coordinates are 0 in all the 3 points, we can consider the charges are kept in z axis in one line. Okay, so our dipole moment will be also in the z axis. Alright, now what is the dipole moment? Now just place, I have placed all these 3 charges. Now I just wanted to write their coordinates. This is at 0, this is at minus a, and this is at plus a. Okay, now how to find out the dipole moment? Just write its product, minus a into minus q. Okay, minus a into minus q plus 0 into q plus a into 2q. So that's equal to aq plus 0 plus 2 times aq, which is equal to 3 times aq. This is the dipole moment. Okay, so dipole moment is 3aq along z axis because it is kept in all the charges are in z axis. So your option is option B. Now just let us check whether it is depends on the origin. Now here we have taken this minus q is at origin, that is 0, 0, 0. Now what I am doing is I am placing this as at the origin 0, 0, 0. Okay. Now this would be, if this is 0, this is at a distance a, so this would be a, this would be 2a. Okay. Now let us write down the each dipole moment. 0 into, this is 0, so this is 0 into minus q, 0 into minus q, plus a into minus q, a into minus q, plus this is 2a, this would be plus 2q, so 4 times aq. So what is the answer? This is 0 minus aq plus 4aq. That would be, dipole moment will be 3 times aq. Right. Now let us check if the, what if the origin is this. If this is the origin, this would be minus a, this would be minus 2 times a. Right. We are going back at every unit as minus a. Okay. Now this would be minus a into minus q, that is minus 2 times a into minus q, plus minus a into minus q, plus 0 into 2q, minus 2a into minus q, that is nothing but 2aq, plus minus a into minus q, that is equal to aq plus 0, which is equal to 2aq plus aq is 3aq. So wherever is the origin, whether this minus q is at the origin or plus 2q, or minus q is at the origin or plus 2q is at the origin, anywhere the dipole moment remains same. So this is independent of origin, independent of origin. Now one more thing, this is in z axis. If the origin is in x or y, at any point x, y or z, any point, if you take the origin at any point, even then the dipole moment will remain same. An electrostatic field is said to be conservative when the curl of the electric field is 0. This is what is your answer, del cross E equal to 0. Now not only electric field, any field is conservative when, let me write any field f. Any field f is conservative if del cross f is equal to 0. What do you mean by conservative? If you make work done along this field in closed path equal to 0, work done along this closed path will be equal to 0 in this field. Now what is divergence of electric field is 0. Option A, divergence of electric field equal to 0. This is the first Maxwell's equation, equal to 0 in source free region. Now what is del dot T? Del dot T is actually equal to rho by epsilon naught del dot E. Gauss law in divergent form. Okay. Now curl of the electric field is equal to minus dou by dot T. This is del cross E is equal to minus dou B by dou T. This is also not a source free region. This is nothing but second Maxwell's equation. Laplacian of electric field, that is del square E equal to 0. What is it actually? Del square V is equal to minus rho by epsilon. Laplacian of potential. And if this is 0, then rho equal to 0. If this is equal to 0, which implies rho equal to 0. Rho means again it is a source free region, or you can write free space. In free space, del square V equal to 0, del dot E is also equal to 0. But in this question, please remember, if del cross F, if F is any field, if del cross F equal to 0, then the field F is said to be conservative. Magnetic field of an infinitely long ideal solenoid of radius r carrying a current I. Now let us first take a finite solenoid of some length L. Okay, now I want to find out the magnetic field at this point. Let me call this point as P and consider these two ends, A and B. A and B are at finite distance. Now this P, with respect to P, this is at an angle alpha. A is at an angle alpha. Similarly, B is at an angle beta. Then the magnetic field inside, that means inside a point P, inside the solenoid at a point P, that means B inside is given by mu naught N I times sine alpha plus sine beta by 2. Now what is this small letter n? N is number of turns, capital N, that means number of turns divided by length. If it is of length L, that much length. Okay, so N is number of turns per unit length or length, total length. So mu naught N I we have already discussed, that is the current, by 2 into sine alpha plus sine beta. Now suppose this is A is at infinity and B is at infinity, then this solenoid will become infinitely long solenoid. Then what happens? Alpha and beta will become 90 degrees. Okay, alpha and beta will become 90 degrees. Then what we have, B inside will be alpha and beta are 90, means sine alpha plus sine beta equal to 1 plus 1, that is nothing but 2. So mu naught Ni. So this is the magnetic field inside an infinitely long solenoid. Okay, so which is constant. Now inside the magnetic solenoid, the magnetic field will be very closely placed. Okay, magnetic field lines will be very closely placed, and outside the solenoid your magnetic field will be this way. Now we consider with respect to inside the magnetic field outside is nearly equal to 0. So magnetic field outside, B outside solenoid is 0. So magnetic field is 0 outside the solenoid and is constant inside the solenoid. What constant value is nothing but mu naught Ni.
Question number 30. The electric field of the electromagnetic wave in SI unit is given by, we have the electric field here. Now the magnetic field of the electromagnetic wave is, so once the electric field is given, we are asked to find the magnetic field. Okay, now let's start writing the electric field. What is electric field? We will rewrite making the sign value constant. So E of r comma t, space and time, is equal to E naught times sine of omega by c into ct plus z. This becomes the phase of the wave times 2x plus 3y or 2x cap plus 3y cap. So this phase tells us ct plus z. So ct plus z is the phase, which means the wave is moving in negative z direction and it is moving with velocity c. So negative z direction is the wave motion. The formula. Now how to calculate B? We know the Maxwell's equation from Maxwell's equation of plane wave in vacuum. We can write del cross E equal to minus dou B by dou T. Now what is del? Del is, this is x direction, let's write x direction, y direction, z direction, dou by dou x, dou by dou y, dou by dou z, x component of E, y component of E, and the z component of E. So this is what we need to calculate. Del cross E equal to minus dou V by dou T. Now since the wave is moving on the z direction, the x direction and y direction won't be present. Now let's understand this better. So x cap into cross product of this, so that is dou by dou y of Ey minus dou by dou z of Ey. So this is x component plus y component of dou by dou x of, there is a minus sign when you come to second. So dou by dou x of Ez minus dou by dou z of Ex. Wait a minute, This is dou by dou y of z minus dou by dou z of this is x ez. Okay, sorry. Z. So y z z y. Okay, fine. Plus z cap into dou by dou x of ey minus dou by dou y of ex. Now from the question, there is no z component for electric field is absent. Why absent? Because it is moving along z direction. That means wave propagates along minus z axis. So if E is a function of x comma y or moves in xy plane, then the magnetic field also will be moving in xy plane. So from here we can remove the z component, and here the first term gets cancelled because there is no z component for electric field, and here also z component with respect to x. Now we get the magnetic field B is equal to, or dou B by dou T equal to del cross E. This is a formula that we get. So del cross E, we can write it as x cap into, or minus x cap into dou by dou z of Ey, and here minus of minus plus y cap into dou by dou z of Ex. Now we have the electric field component E not equal to sine of omega by c into Ct plus h times 2x cap plus 3y cap, and from the Maxwell's equation, del cross E equal to minus dou B by dou T, and which is given by minus x cap into dou by dou Z of Ey plus y cap into dou by dou Z of Ex. So now let us define the term omega by c times Ct plus Z equal to phi. Now let us see what is d phi by dz. d phi by dz will be equal to omega by c. It's equal to omega by c. Now let us rewrite Ey is equal to 3 times E naught into sine of phi, and Ez equal to 2 E naught into sine of phi, or sine phi. Yeah. Now what is dy by dz? That's equal to 3 E naught into derivative with respect to z, so this becomes cos phi into d phi by dz. Similarly, this is dEy. Now d e so this is x. So dex by dz equal to 2 E naught into cos phi into d phi by dz. Now replace this d phi by dz divided by, we already know omega by c, so 3 e naught omega by c into cos phi times and here we have 2 e naught cos phi omega by c. Okay, now minus dou b by dou t of x the x component, dou b x of by dou t equal to minus 3 times e naught omega by c into cos phi. From this we can write dou b x by dou t equal to 3 e naught omega by c into cos phi. Similarly, we have minus dou b y by dou t equal to 2 e naught omega by c cos phi, which is equal to dou by by dou t equal to minus 2 e naught omega by c into cos phi. But we already know what is phi. Phi is equal to omega by c into ct plus z. That is equal to, just multiply omega t plus omega z by c. Now let us differentiate with respect to time. D phi by dt equal to omega. Now let us find what is d by dt of sin phi. D by dt of sin phi is nothing but cos phi times d by dt of phi. So that's equal to d by dt of phi is nothing but omega. So omega cos phi, or we can write it as omega times cos phi dt equal to d of sin phi. Now let's consider integration. Now here we have two equations corresponding to 1 and 2, x and y. So we need bx. Bx is nothing but the x component of the magnetic field, is nothing but integral dB by dt or dou b by dou t x component into dt, that's equal to integral 3 e naught omega cos phi divided by c times dt. But we already know that omega cos phi dt equal to d sin phi. So replace this omega cos phi dt with that. So bx will be equal to integral 3 e naught by c omega cos phi dt is d sin phi. That will be equal to 3 e naught by c integral d sin phi is sin phi. Similarly, we can write the y component will be integral of this, that will be equal to 2 e naught by c sin phi. Now replace and let us rewrite. B is equal to 3 e naught by c into, that is x component, plus x component sin phi. Okay, we'll write sin phi later, minus 2 e naught by c y cap into sin phi. So this can be again simplified. E naught by c into sine of omega by c into ct plus z into 3x cap minus 2y cap. This becomes the magnetic field.
Expectation value of z coordinate in the ground state of hydrogen atom. The wave function of the hydrogen atom in ground state is given as a e power minus r divided by a naught. A is the normalization constant and a naught is the Bohr radius. Now expectation z is nothing but expectation r cos theta, because z is nothing but r cos theta in spherical polar coordinates. Now since this is a hydrogen atom problem, this is three-dimensional problem, 3D, we can take spherical polar coordinates. Then expectation z is nothing but integral psi star z psi d tau. Why d tau? We have already mentioned it is a 3D problem. Now what is psi? Psi is nothing but a e power minus r divided by a naught. Integral a e power minus r divided by a naught. Z is nothing but r cos theta into psi. Psi is a e power minus r divided by a naught into d tau. What is d tau? D tau is equal to r square dr sin theta d theta d phi. R square dr sin theta d theta d phi. Small volume in three-dimensional spherical polar coordinates. Now just substitute these values. What you are getting is a square integral my e to the power minus r 2r divided by a naught into r into r square is nothing but r cube dr integral sin theta cos theta d theta. Sin theta cos theta d theta. This is from 0 to pi and into integral 0 to 2 pi d phi. Okay, and this integration is from 0 to a naught. Now let us take this integral 0 to pi, integral 0 to pi sin theta cos theta d theta. This we can write it as sin 2 theta divided by 2 into d theta, because 2 sin theta cos theta is nothing but sin 2 theta. 2 sin theta cos theta is nothing but sin 2 theta. Now this integral is nothing but 0 because sine to theta from varying from 0 to pi, which means 0 to 2 pi, which varies, sine theta varies from 0 to 2 pi. That will become 0. So the entire integral become 0, which means expectation z is 0. So expectation value of z is 0. So please remember from this what is z is equal to r cos theta, and the wave function of hydrogen atom psi is equal to 1 by under root pi a naught cube into e to the power minus r divided by a naught. This is the normalization constant. 1 by pi a naught cube is the normalization constant for hydrogen atom. A particle is placed in a one-dimensional box with rigid walls. The first excited state energy of the particle is 4 electron volt. The ground state energy is. Now this is the one-dimensional box of length L, and at x equal to 0 and x equal to L you have rigid walls, which means the potential is infinity. That means the particle cannot cross this barrier and go. Then what is energy? Energy is given by n square pi square h cross square divided by 2m L squared. This is the nth state energy. Nth state, not the nth excited state, where n is the nth state. Okay, now ground state means n equal to 1. First excited state means n equal to 2. Now all these quantities are constant. Pi square is constant, h cross square, 2m L square, this is constant. So your En is equal to n square times E naught. Okay, that means En equal to 1 means pi square h cross square divided by 2m n square. This we are writing it as E naught, or let me write it as E1. Okay, this is given as the first excited state energy. That means E2 is equal to n square, that let me write it as 2 square into E1. Okay, what is the question? Ground state energy E1. This is the what is the question is. Then E1 will be equal to E2 divided by 4. What is that value? 4 divided by 4 electron volt divided by 4, which is nothing but 1 electron volt. This is the ground state. So option C is your answer. Now if the question is find second excited state, then what will be your answer? Second excited state is n equal to 3 square into E1. What is E1? 1 electron volt, that is 9 electron volt. Similarly, third excited state would be 4 square, that is 16 electron volt. So it goes on. Okay, so here your answer is option C, 1 electron volt. That is the ground state energy. Please remember this formula. En of one dimensional square well potential.
(33) The wave function in momentum space is given by phi of p is equal to, let us write down, phi of p equal to n divided by p square plus alpha square, where p is the momentum and n is the normalization constant, alpha is some constant as given. Then the corresponding wave function in the configuration space. Now in quantum mechanics, let's understand the question. In quantum mechanics, a particle can be represented by the state of the particle. The particle state is represented either in momentum space, that is p space, or k space, anything is okay, or the position space, momentum space or position space. So here in momentum space we write psi of p, and in position space we write psi of r. So this is how we describe a particle in quantum mechanics. Now these two are connected by a transform called Fourier transform. You can move from one space to another using this transformation, Fourier transform. What is a Fourier transform? We have already seen psi of x equal to 1 divided by root of 2 pi h cross integral from minus infinity to plus infinity phi of p e to the power I px by h cross dp. Okay. Now the question says we need not worry about the constants, so we can write psi of x is proportional to integral from minus infinity to plus infinity phi of p e to the power I px divided by h cross into dp. Now that can be written as let's replace this phi of p with its values. So integral from minus infinity to plus infinity e to the power I px divided by h cross divided by p square plus alpha square times dp. Now from the complex analysis, we know integral from minus infinity to plus infinity e to the power I k z divided by I k, let's write x, I k x divided by k square plus a square dk equal to pi divided by a e to the power minus a mod x. So now replace the terms. Here we have, instead of k x now we have, instead of x we have x by h cross, for k we have p, and instead of alpha we have a. So pi divided by alpha e to the power minus alpha, instead of x we have x by h cross. Now this is an exponentially decaying function. So the in momentum space we have 1 divided by p square plus alpha square. Its momentum space in position space you have exponentially decaying function. (34) The eigenstate of the momentum p with eigenvalue p naught for a particle of mass m in momentum space momentum representation is. Now here we are given the eigenstate. Let's write it as psi of p with respect to the momentum, and the operator p is the momentum operator. And similarly we also are given eigenvalue which is p naught. Now for the eigen operator or the momentum operator p which is acting on psi of p, that is the eigenstate, gives us p naught into psi of p. So this is the operator, this is the eigenstate, this is the eigenvalue, and this is the wave function or eigen function. So let's write eigen function. When the momentum operator acts on the eigen function, you get eigenvalue times the eigen function. Okay. Now we need to calculate what is this eigen function. What is the value of eigen function such that when the momentum operator acts on the eigen function, you get p naught times eigen value. Now from here we can write p acting on psi of p minus p naught times psi of p equal to 0. Now this is p naught. So p minus p naught times psi of p equal to 0. Now this indicates that at every point other than p equal to p naught. So when p equal to p naught, it is 0, there is no issues. But if p is not equal to p naught, then psi of p must be equal to 0. That means at every point other than p equal to p naught, psi of p equal to 0. Now if you consider the momentum space from minus infinity to plus infinity, suppose this is p equal to p naught. At this point you have a wave function, and in all other point the wave function is 0. This is similar to Dirac delta function or Dirac function. What is the Dirac function here? Delta of p minus p naught is what is we need. Okay. If the operator a comma b commute, then which of the following is true for their common eigenstate? Now let us see what you mean by commutation. So if a comma b commutes, then the value is 0. We have the uncertainty relation, relation as delta A into delta B is greater than equal to the half times the magnitude of A comma B, commutator A comma B. Now if this operator commutes, A dot B is 0. So right hand side here it will be 0. Now what does that mean? If you have a common eigenstate, if you have, then A comma B will be equal to 0, which means delta A into delta B equal to 0. This implies that there is no uncertainty in measurement of A and B values. That means there is uncertainty in A and uncertainty in B equal to 0 simultaneously. Now A and B simultaneously, which means A and B can be measured with accuracy. Okay, so delta A equal to 0, delta B equal to 0. According to the question, the option 4th is the correct answer.
The first excited state of two-dimensional harmonic oscillator under the potential V is given. V of x comma y half m omega square into x square plus 4y square. And the question is the first excited state energy. The question is about first excited state energy. Okay. Now this we can write it as this V potential V is equal to half m omega square x square plus half m omega square into 4y squared. Okay, so this we need frequency, right? So this is omega square x square and this is omega square 4y square. Now what we are writing is half m omega x square into x square plus half m omega y square into y squared. Now here we can write omega x equal to omega, and here omega y is equal to 2 times omega. Alright, because we have converted this 4y square omega square into omega y square into y square. So 4 omega square is equal to omega y square, which means omega y is equal to 2 omega. Alright. Now in ground state, what is the energy? We need half h cross omega, which is nothing but we can write it as n plus half h cross omega is the energy of nth state. For n equal to 0, we will write half h cross omega. This is the ground state. So for both dimension we can write the ground state energy, that is equal to half h cross omega x plus half h cross omega y. Now that's equal to, what is half h cross omega x is nothing but omega, plus half h cross omega y is nothing but 2 times omega, which means half h cross omega plus h cross omega. Alright, half h cross omega plus h cross omega, which is nothing but 3 by 2 h cross omega. This is ground state energy of this harmonic potential of that particle. Okay, now we need first excited state. First excited state means n is equal to 1. Now n is equal to 1 means nx plus ny should be equal to 1. The least value nx can have is 0, and least then your value will be ny equal to 1. There are two possibilities, or nx equal to 1 or then ny equal to 0. Then you can write the energy E is equal to nx plus half h cross omega plus ny plus half into h, this omega x into h cross omega y. This we can write it as nx plus half h cross omega x, you can write it as omega because omega x equal to omega, plus ny plus half h cross into 2 omega. Now if I put nx equal to 0 and ny equal to 1, nx equal to 0 and ny equal to 1, what is the value I am getting? Nx equal to 0, that is half h cross omega, and ny equal to 1, 3 by 2 into 3h cross omega plus 3h cross omega, which means 7 by 2 h cross omega. Now this is an energy state, but whether it is first excited state we have to check. Now just put nx equal to 1 and ny equal to 0. If nx equal to 1, your value will be 3 by 2 h cross omega plus half h cross omega, half into 2, that is 1 h cross omega, so that is equal to 5 by 2 h cross omega. So 7 by 2 is greater than 5 by 2, which means this is the first excited state and this is the second excited state. So first excited state will be 5 by 2 h cross omega. The wave function of the hydrogen atom is given by psi is equal to 1 by root 3 psi 210 plus psi 310 plus psi 420, where psi, n, l and me stands for, n stands for principal quantum number, and L stands for angular momentum quantum number. And what is ME? ME stands for orbital angular momentum quantum number. Okay, ME. Now look at the wave function psi. Psi is a combination of psi 210, psi 310 and psi 420. Now all the wave function of which psi is the superposed wave function, in this ME value is same, which means all are eigenstate of ME. And what is ME? ME is nothing but orbital angular momentum quantum number, which is nothing but LZ, orbital angular momentum LZ.
At a given instant of time, a rigid rotator is in the state psi of phi comma theta or theta comma phi equal to root of 3 divided by 4 pi times sine theta into sine phi. The measurement of LZ in units of h cross. So we need LZ in the unit of h cross, some h cross. We'll find the value which of the following possible values. Now we have already given the state. Now for spherical harmonics, for L equal to 1, angular momentum L equal to 1, we can write psi 1 plus or minus 1. So this becomes the L value and corresponding ML value. So ML value equal to minus 1, 0, 1, like that. So 1 plus or minus 1 of theta phi equal to minus plus. This will become minus, for minus 1 it will become plus 3 divided by 8 pi. This is according to the spherical harmonics. Sine theta into e to the power plus or minus I phi. Now this is from spherical harmonics. Now from the question we have psi of theta comma phi equal to root of 3 by 4 pi, just rewriting the question, sine theta into sine phi. Now let us rewrite what is sine phi. Sine phi, exponentially we can write e to the power I phi minus e to the power minus I phi divided by 2i. Now replace this sine phi here. So put the value of sine phi here. Then we will get psi of theta comma phi equal to root of 3 by 4 pi sine theta 1 by 2i into, we can bring sine theta inside, so it becomes sine theta into e to the power I phi minus sine theta into e to the power minus I phi. Okay, so this is our wave function now. So the spherical harmonics, from spherical harmonics we write y1 plus 1 of theta phi equal to, so if it is plus 1 we have to write minus root of 3 by 8 pi sine theta into e to the power plus I theta. So this corresponds to plus 1. Similarly, y1 minus 1 of theta comma phi equal to, since it is minus, here plus, root of 3 by 8 pi sine theta into e to the power minus I theta. Now here we have psi of theta comma phi. Now bring this into this form. This becomes, now before that, from these two equations let us find out what is sine theta e to the power I plus theta equal to minus of root of 8 pi by 3 times y of 1 plus 1. Similarly, sine theta e to the power minus I theta equal to root of 8 pi by 3 times y of 1 comma minus 1. From these two equations we get what is sine theta e to the power plus I theta and sine theta e to the power minus I theta. Now we have this as equation 1, 2 and 3. Now substitute 2 and 3 in the equation 1. We get psi of theta comma phi equal to root of 3 divided by 4 pi times 1 by 2i into sine theta e to the power I phi is minus root of 8 pi by 3 y1 plus 1 minus root of 8 pi by 3 y1 minus 1. Now root 3 and root 3 from here will get cancelled. 4 pi and 4 pi also can be cancelled. So what is remaining is 1 divided by root 2i into minus y1 plus 1 minus y1 minus 1. So here we can rewrite. So minus 1 you can take it out. So minus 1 divided by root 2i y1 plus 1 plus y1 minus 1. So this will be the combination of two states, y1 plus 1 and y1 minus 1. So minus 1 you can write it as minus 1 equal to I into I square. So I and I get cancelled. So that will become I divided by root 2 into y1 plus 1 plus y1 minus 1. So here the values of L is plus 1 and minus 1. The Hamiltonian of a spin half system is given by, so H is equal to minus alpha times sigma dot B, where alpha is greater than 0 and B is the external magnetic field. The energy eigenvalues, we have to calculate the energy eigenvalue. Now the sigma is nothing but the Pauli's spin matrix. And the property of Pauli's spin matrix is that sigma dot B whole square equal to B squared times I. They follow this relation. Now from this we can understand that magnetic field plus or minus magnitude of the magnetic field is the eigenvalue. The operator sigma acts on B, you get B times some value. Similar to this, operator A acts on the wave function equal to lambda times psi. So magnetic field you have operator, so A psi gives you lambda psi, so this lambda becomes the eigenvalue. Similarly here B becomes the eigenvalue. Now if the B is the eigenvalue, from the Hamiltonian as given in the question, H is equal to minus alpha sigma dot B. So this is the Hamiltonian. You can write energy is nothing but the eigenvalue. So since in the Hamiltonian you have the minus alpha term, you can write the energy as minus alpha into plus or minus magnitude of B. So that's equal to plus or minus alpha magnitude of B is the energy eigenvalue corresponding to the given Hamiltonian for spin half system.
Suppose we have two non-interacting particles, both of mass m, in one-dimensional infinite square well potential 0 less than or equal to x less than or equal to a. If the particles are identical bosons, then the wave function of the first excited state psi of x1 comma x2 is given by. Now psi of x1 comma x2, if it is given, they are asking about space wave function. Space wave function. Now here is the ground state. Ground state means both the particle 1 and 2 are in state 1. But the question is about first excited state. First excited state means you have two states, psi 1 and psi 2, and the particles are distributed as either this one or it is distributed like this. That means both are possibilities. That means psi 1 will have first particle and psi 2 will have the second particle, or psi 1 will have the second particle and psi 2 will have first particle. Okay, so this is nothing but first excited state. Our psi will be a combination of both 1 and 2. Then our wave function, required wave function psi, will be equal to n into psi 1 of 1 into psi 2 of 2. What does that mean? First particle in psi 1, second particle in psi 2, plus second particle in psi 1, first particle in psi 2. Okay. Now what is psi 1 of 1? Psi 1 of 1 means the position of the first particle in psi 1. That is given by under root 2 by a sine pi x1 by a. This x1 indicates the position of the first particle. Okay. Psi 1 of 2 will be under root 2 by a sine pi x2 by a. This 2 indicates the position of particle 2. Okay. Then, and what is psi 1? Psi 1 just implies that is n equal to 1. What is n equal to 1 means? State. Now psi 2 of 1 is under root 2 by a sine 2 pi x1 by a. Why 2 pi x1 by a? Because it is state 2. We know for one dimensional box it is under root 2 by length of the box into sine n pi x by a, where A is the length of the box and n is the state. Similarly, psi 2 of 2 means under root 2 by a sine 2 pi x2 by a. So we got what is psi 1 of 1, psi 2 of 2, psi 1 of 2 and psi 2 of 1. Now we need what is n. N is nothing but normalization constant. It is given by under root n1 factorial into n2 factorial divided by s factorial. What is n1? n1 is number of particles in first state and n2 is number of particle in state 2. And what is s? S is number of states. Now here n1 is nothing but 1. There is only one particle in state 1. n2 is 1. So value of n is nothing but under root 1 factorial into 1 factorial by 2 factorial, which is nothing but under root 1 by 2. Okay. So we have all the values. N is also ready. Just substitute the value of n, psi 1 of 1, psi 2 of 2, psi 1 of 2 and psi 2 of 1. You will get something like this. Just take out 2 by a into 2 by a, which is nothing but under root 2 by a into under root 2 by a, which is nothing but 2 by a. Bring it outside, which will become, when multiplied by 1 by under root 2, will become under root 2 by a into sine pi x1 by a into sine 2 pi x2 by a plus sine pi x2 by a into sine 2 pi x1 by a. So which is your answer is option C. Now this is only when your psi is symmetric. That means psi space. We know we are talking about space wave function. If this would have been minus if psi space is anti-symmetric. Okay. Alright, so that's about this question. So please remember these things. What is total wave function psi and how you calculate n, normalization constant n, as well as the wave function of one-dimensional box. A quantum system with energy levels n h cross omega, where n equal to 0, 1, 2, etc. up to infinity, is in equilibrium at temperature T. The partition function characterizing the system is given by. Partition function is given by z is equal to sum over s e power minus beta es, where beta is equal to 1 by kt. K is Boltzmann constant. Okay. Now, and what is es? Es is nothing but nh cross omega. That is the energy of the level. Then, since our energy levels are from 0 to infinity, we can write n equal to 0 to infinity e power minus beta es. Just substitute the values of beta and es. What we are going to get is sum over n equal to 0 to infinity e power minus beta es. Es is nothing but nh cross omega. Now we can rewrite it as sum over n equal to 0 to infinity e power minus beta h cross omega into whole power n. Now sum of n equal to 0 to infinity x power n is equal to 1 divided by 1 minus x. Now this is when x is less than 1. Okay. Now that's equal to 1 divided by 1 minus e power minus beta h cross omega. Now just substitute what is beta. You will arrive at your answer. 1 divided by 1 minus e power minus h cross omega by kt. This is the partition function. So your correct option is option D. So please remember this. Sum over x power n from n equal to 0 to infinity is 1 divided by 1 minus x.
42. Statistics of indistinguishable particles goes over the statistics of distinguishable particles when now in quantum mechanics we have two kinds of indistinguishable particles, that is statistics we have for distinguishable and indistinguishable. Now distinguishable particles are Maxwell-Boltzmann, governed by Maxwell-Boltzmann. Here indistinguishable Fermi-Dirac, that is fermions, and Bose-Einstein for bosons. Now at the limits of quantum mechanics, the indistinguishable particles or the statistics governed for indistinguishable particles such as fermions and bosons will behave similar to that of distinguishable one when in one of these following cases. Okay, one of the following options, the limit will tend to, that means distinguishable one will be overlapping with indistinguishable, and that limit is what we are going to see. Now for that particular relation where the quantum mechanic or quantum statistics reduces to classical statistics. This is what is meant by the question, classical statistics. This happens when there is low density for particles, which means dilute system. Dilute system means number of particle will be less, number of particle is less, and the number of states is more. When the particle is less and the number of states available for them to occupy is more, such kind of system is called diluted system, and number of particle is given by the letter n and number of state is given by letter g. Now n by g, That means number of particle and number of state. N by G is very much less than 1. This is what is the limit for when quantum statistics reduces to classical statistics. So according to the option, the number of state is much larger than number of particles. Option A. A reversible adiabatic process is. Now let's analyze what is adiabatic. Adiabatic process. Adiabatic process is when there is no heat transfer. No heat transfer, which implies dq is equal to 0. Now from thermodynamics, the entropy change ds is equal to dq in a reversible process divided by t, or dq equal to tds. Now we know on the right hand side it is 0, so ds has to be equal to 0. If ds is 0, s is constant. So the process is isentropic process. Option C. Average energy of a photon gas at temperature T equal to 1 by kb, where the energy levels are given by Ej equal to j h cross omega, j equal to 0, 1, 2, etc. Now average energy, we have to first find out the partition function. So partition function z is equal to sum over j equal to 0 to infinity e raised to minus beta ej. Now this is equal to 1 divided by 1 minus e to the power minus beta h cross omega. Because we know already Ej equal to h cross omega, j h cross omega, where j is 0, 1, 2, etc. So according to this, if you can rewrite this, it will start from 1 plus e to the power minus beta, j is 1, h cross is h cross omega, plus e to the power minus 2 beta h cross omega. So this is a series which accumulates to 1 by 1 minus e to the power minus beta h cross omega. So this is the z. That is the partition function z is equal to 1 divided by 1 minus e to the power minus beta h cross omega. So z we have got. Now the average value of the energy. Average energy of the photon is given by minus dou by dou beta of log z. So now we need to compute the log z. So log z is equal to log of this particular value. So that will become minus, since it is in the denominator, minus log of 1 minus e to the power minus beta h cross omega. So log z equal to minus log 1 minus e to the power minus beta h cross omega. Now we need to differentiate with respect to beta. Log x derivative is no, let's start with the function itself. The average value of E equal to minus dou by dou beta of minus log 1 minus e to the power minus beta h cross omega. Now this we can rewrite as dou by dou beta, minus and minus get cancelled, dou beta of log of 1 minus e to the power minus beta h cross omega. Now derivative of log x 1 by x, so 1 divided by 1 minus e to the power minus beta h cross omega into derivative of what is in the bracket. So e to the power minus e to the power, so minus sign will be there, minus 1 into derivative of e to the power x, e to the power x only, so e to the power minus beta h cross omega, again chain rule continues. Minus beta h cross omega is nothing but minus h cross omega. With respect to beta we are differentiating, so now we get this is equal to h cross omega divided by minus and minus, that plus h cross omega e to the power minus beta h cross omega into 1 minus e to the power minus beta h cross omega. So multiplying and dividing by multiplying the numerator and denominator by e to the power minus beta h cross omega, we get h cross omega divided by e to the power beta h cross omega minus 1. So it's option. There are 3 possible energy states for a system of 2 particles. Assuming Maxwell-Boltzmann, Bose-Einstein and Fermi-Dirac statistics, the number of possible states for the system are, so number of energy states, so number of energy states G equal to 3. Similarly, number of particles is also given, number of particles N equal to 2. Now according to Maxwell-Boltzmann, we have the number of possible states omega of Maxwell-Boltzmann is equal to G to the power N. So G is 3, 3 to the power N is 2, so that's equal to 9. So 9 possible states are there for Maxwell-Boltzmann. Similarly for Bose-Einstein, we have G plus N minus 1 C N. So that's equal to G plus N 2 plus 3 5, 5 minus 1 4, 4C N is 2, so 4C2 is 4 factorial divided by 2 factorial into 4 minus 2 factorial. So 4 factorial divided by 2 factorial into 2 factorial, which is equal to 6. Now let's see for Fermi-Dirac, number of available states, possible states. For Fermi-Dirac, it is GCN, which is equal to G is number of states, that is 3C2, that's equal to 3 factorial divided by 2 factorial into 3 minus 2 factorial, so that's equal to 3. So 9, 6 and 3 is the answer. N particles are distributed among the 3 states E equal to 0, E equal to kT and E equal to 2 kT. If the total equilibrium energy of the system is 1000 kT, the value of N is closest to. Now we have N particles and energy states are 0, so EI equal to 0, or let's write E1 equal to 0, E2 equal to KT, and E3 equal to 2KT. Then the partition function Z equal to sum over e to the power minus EI divided by KT. That's equal to, substitute for each one. So e to the power 0 plus e to the power minus KT by KT plus e to the power minus 2KT by KT. Substituted 0, minus KT and 2KT in the formula. So now we have Z, the partition function Z equal to 1 plus e to the power minus 1 plus e to the power minus 2. Now these are the probabilities corresponding to each energy states. So now let's find out the average energy. Average energy will be equal to first probability into the energy, that is 1 into 0 plus KT into e to the power minus 1 plus 2KT into e to the power minus 2 whole divided by the partition function Z. Now instead of this we can write KT e to the power minus 1 plus 2KT e to the power minus 2 divided by 1 plus e to the power minus 1 plus e to the power minus 2. Now substituting the value of E is equal to, or e to the power minus 1 is equal to 0.36 and e to the power minus 2 equal to 0.27. You generate 368, this is 0.27. Then KT into 0.368 plus 0.27 divided by 1 plus this much. So 1 plus 0.368 plus 0.27. So it accumulates to KT times 0.424. Now this is equal to, average energy is given as 1000 KT. So KT gets cancelled. This much into N into KT into this much. So N is equal to 1000 divided by 0.424, which counts to 22,400, almost equal to 2,400 particles. This is average energy. When you multiply by the N, you get the total energy. So option D. Avalanche photodiodes are preferred over PIN diodes in optical communication system because according to the answer key, it is given as C, but I have serious doubts regarding this question, and to get a more clear picture, I have given the table consisting of PIN photodiode and avalanche photodiode, some of its properties. You can get some more information from this chart. PIN photodiode indicates P stands for uh, P doped material, I intrinsic, and N type. That means it's a type of semiconductor where you have N type or P type, N type, and here there is no doping, without doping. This is called pin type photodiode. Uh, Coming to the internal gain, uh, for pin diode it is unity, and avalanche it has got higher internal gain. This is avalanche means a burst of photons or electrons, burst of electrons. So there's a huge uh, arrival or giving out of electrons. So there is higher internal gain. Sensitivity in the case of pin diode it is moderate, and in the case of avalanche diode it is much higher, and it is to detect weaker signals, mainly for weaker signals. Bandwidth is higher for pin diode, and the response is also faster because of its higher bandwidth. Avalanche has lower bandwidth because of the lower process time. Okay, noise, lower noise, but avalanche has higher noise because it is uncontrolled. Bias voltage operates between 10 to 20 volt. It requires high reverse bias voltage, which is around 50 to 200. Now complexity, simple design, and it is easy to operate. Complex design requires stable high voltage supply. Power handling is moderate, and in the case of avalanche it is noise dominant. Cost is cheaper while avalanche is more expensive. It is used in high speed short communication, while avalanche is used for long distance optical communication. In 8085 microprocessor system with memory mapped IO, which of the following statement is correct? Now, the microprocessor communicates with the external devices through mapping. So, mapped IO mapped IO, and memory mapped IO. These are the two schemes by which a microprocessor system will communicate with the external devices such as keyboard, mouse, etc. Okay, now the question is about the memory mapped IO. Now here IO devices, it says that IO devices have 8-bit addresses. No, it has 16-bit addresses, and IO devices are accessed through in and out instructions. Now in and out instructions are for isolated IO. Isolated IO is nothing but IO mapped IO, isolated IO, or IO mapped IO, and not for the memory mapping. Okay, so now there can be a maximum of 256 input devices and 256 output devices. Now this is also for isolated IO. This is also for isolated IO or IO mapped IO, not for the memory mapping. For memory mapping we can have up to 64 KB. Okay, now the last one, arithmetic and logic operation can directly be performed with IO data. Yes, This is the correct statement with respect to the memory mapping. So option 4 is the correct. To get more idea regarding the isolated IO and memory mapped IO, a tabular column is made here. Feature address space in memory in isolated IO, we have a separate address space for input and input output devices having 8-bit and 256 ports. Now for the memory mapped IO, it shares the same address space with the memory. They do not have a separate space. 16-bit and 64K addresses. Now instructions used, special instructions are used for in and out. Normal memory instructions for arithmetic and logic operations on IO data. It is not directly possible in isolated IO. It's possible in memory mapped IO. Memory space impact. Memory space is, since it is having separate memory, memory space is not reduced by IO. Part of the memory address space is consumed by IO in the case of memory mapped IO. Needs separate control signals, while the memory mapped IO do not need. It's a similar hardware, same memory control lines are used. The diode that has negative resistance characteristics is Schottky, tunnel, laser and Zener. The actual answer for the question is, it is tunnel diode. Now tunnel diode is a special type of diode that exhibit negative resistance due to quantum tunneling effect. So it's due to quantum tunneling effect. Now what happens in this effect? The VI characteristics or IV characteristics curve, when voltage increases, the current decreases. So this is where you have negative resistance. The property is useful in high frequency oscillators. So application is high frequency oscillators. Or microwave circuits. Okay, now coming to the other options, the Schottky is fast switching diode. Some of the features we will discuss. Fast switching diode, and now laser diode. It emits coherent light. It is used for coherent light source, mainly used in applications with the communication application. Now Zener diode, it always works in reverse bias. Then used in voltage regulation. Okay.